All right, great. So, like I was saying, I would like to share some of the solutions you guys made, and you see, I kind of split it out into different parts. Oh, I probably didn't check my email then. I didn't take a look at it. But let's start with Chinoso's version. So we see here Chinoso was solving the currency converter. Remember, the question for the currency converter was more of, let me see, where was that question again? Just give me a minute. Yeah, that was this one. So I wanted the program to, first of all, ask you as the user uh, what the conversion rate is between €1 to Naira, and then when you tell the program what 1 euro the Naira value is of €1, then the program is to ask you how much you intend to convert, and when you give the program that, it's going to tell you how much everything costs. So if we look at Chinonso's version, and I really enjoy the fact that everyone was trying to do something cool with it. So that's pretty cool. So if I run Chinonso's version, she says, what would you like to convert? So that's pretty cool, because you could choose one. It says euro to naira or naira to euro. So if I say I want to convert, I select one and I push enter. It asks me what amount I want to convert. I say I want to convert 1,500. No, because I want to convert say €1,000, and it tells me the total the total amount in euros. So it's about, how much is this? 1.7 million naira. So that's pretty cool. The only thing is, I would have expected you missed this part where it says you have to ask the user what the conversion rate is from of €1. So I see you had coded it in here, and you told the program that what it was, but actually I wanted you to ask the user that information, like it will tell me what the conversion was, and then it does what it needs to do. So, but pretty good, interesting solution. I like the fact that you're giving options and stuff, so that's beautiful. If we take a look at Constance's own version of the same project, so let's run that. So you see, Constance is like, how much would you like to convert? I would say that I want to convert €1,000, and Constance also gave me a total of 1.5 million naira. And I think, Constance, you also missed the same thing. I would have expected you to ask the user to give you the input of one. So like, you ask the user, what is the euro rate of €1. So the person would output it, and then you now ask the next question. But this is also pretty cool. One thing I liked about this output was trying to make it readable. So I see you put the pound sign, Constance, pounds. Ah, don't forget you're a Dutch girl, eh? So, but it's pretty nice to see that you're trying to make the user see that, okay, this is money. So she put the pound sign. Like, you guys can put the euro sign. So in this case, Constance should have actually put the euro sign, which you see here. You could do quite easily. Um, I'll get to you, Gospel, in a minute. And then yeah, make it like, so this is nice that you made it like more readable to the user. Then if I here, if I is not here, so I'm gonna skip Ifan's version. I will go to Obi. So let's see what Obi has. So if we run Obi's version, you see Obi asks, what currency would you like to exchange today? So this was quite slick. I really like this version. So he said he's asking you, what currency do you want to convert? So I'm like, I want to convert uh, euro, and he says, what currency would you like to change to this? I want to change to naira. Then he says, okay, please input the conversion rate of €1. So he took this variable, this value, and put it here, and took the variable naira and put it here, which is quite cool, because now it says, please input the conversion rate of €1 to naira. Then I say €1 to naira. I think it's like I'd say it's like 1.7 maybe, 1,700. Then it says how much do you want to convert. Now I say I want to convert 1,000 uh, euros, and then it gives me the amount, which is 1.7 million. So the interesting thing about this is very user friendly, so that's nice. But I'm sure you guys know how to do this already. He he took these two variables, used it to formulate the question, which makes it more user friendly, and he also gives you the possibility to convert any currency. So this is quite interesting. And if you combine this with the inputs that we got, the feedback we got from Constance, which is just add euros here, it will make it look even more user friendly. So that's good. So if you want to look at the code of how he did that, that's also, I'm sure you guys can also do the same thing. See, this is where he's asking for the exchange rates. I mean, what you want to exchange, and he put it in the variable from. You see, the variable from is a string, and he got the other word. What would you like to change to? He put that in the to variable, and then he used that to formulate his question, which he says, please input the conversion rate of €1. Then he added the variable, so which made it quite readable, as you can see. Great. I also see Ifeanyi is here, so let's run Ifeanyi's code. I think, yeah, it's no problem. So we're gonna run Ifeanyi's code and see. So Ifeanyi is asking, enter the conversion rate of €1 to Naira. So I'm gonna say the conversion rate is 1.8 this time. It says enter the amount you want to convert. I want to convert 1,000 euros. I push enter, and he says 1,000 euros is equal to this in Nigerian naira. So also I like this solution too, because like I said, it was also quite user friendly. So he's kind of like saying, okay, he took this 1,000 euro you put here. He said the 1,000 euro is equal to this, so it's more user friendly. The user reads it out. Like, oh, okay, I remember I put 1,000 euro and now it's equal to. So the feedback is quite friendly and quite nice. So that's beautiful, and I'm sure you guys also have an idea how he did that using variables, which is very nice, very nice. So we'll look at Sumba's own solution. So let me see, Sumba has a currency converter here. So let's run that. So Sumba is asking, what is the current exchange rate? €1 to Naira. So I'm gonna say current exchange rate is 1,900. How much euro do you want to convert? I want to convert 1,000. And we see she says you get a total amount of Naira. So that's good. This is also beautiful, quite readable, user friendly, very nice. So you see, in all, everybody's doing the right thing. You understand? I think all the answers were pretty correct. I saw even for Nonso and Constance that hard coded the conversion rate. The idea is still the same. The most important thing is I wanted you guys to do calculations and know how to get the results. And it's beautiful to see how everybody's code is different. You see, this is Chinonso's code. You see, Chinonso is using if statement, so she's practicing her if statement. She's doing float conversions, very interesting. You look at Constance own version, quite different, a little bit smaller. So this should also tell you that there are different ways to solve a specific problem. So depending on how you look at it, so you see everybody's code looks somehow different, somewhat different depending on how you look at it. So, and I think this is beautiful. This is exactly what I wanted you guys to do. Use your imagination to make it richer. You see, Obi is asking questions, is playing around with it. Everybody's doing something fun, and that's very beautiful. One other feedback I have for Sumbo and for I think it's only Sumbo I'm seeing this. I've not really checked with others. Whenever you're dealing with money, please don't use integer. And the problem with integer is integer would not hold your decimals. It will not hold your decimal values. And remember, money always has to do with decimals. Money is not a real number. Integer is a real number. Money is not a real number. Money has decimals. So you have like someone is paying 10 euro 50 cents, 1 naira 50 kobo, whatever. Because there's always some extra after the point. And when you use integers will just remove everything that is decimal, and you get only whole numbers. So you want to make sure of your data types, make sure you store it in the right place. So I see most of you try to do that. I think Most of you stored yours in floats, which is the right one to do. Sorry, this was a different one. So I see everything. Most of you actually use floats. So that's one feedback. When you're dealing with money, don't use integers. Integers will remove all your decimals, so you don't want to do that. So choice of data type. We'll go to the next question. So the next one was the age calculator. So I'm going to start with Constance. So I have an age calculator program here. I'm going to run it. Oh, sorry, before I continue, Goswi had his hands raised. Goswi, can you tell me what your question was? Yes, I can hear you loud and clear. Okay, this is IntelliJ. Okay, that I'm very sorry. I should have sent you the program to install. Oh my gosh, that's very important because we do a lot of hands-on here. So what I'm going to do is we have it in the chat here somewhere. I'm just going to forward it to you. So you just have to download it and install it. I really did not remember. I should have asked you to do this before this class, but let me see. I actually thought I'd shared that in this group app. Just give me a minute. Let me. No, you have to install it on your computer. Yeah, let me. Guys, just give me a minute. I will just scroll up to see the link so I can forward it to everyone. I also see Chidi's here. Chidi, good morning. How are you? Chidi's calling in from the United States, and I think it's midnight on his side, and he must be feeling sleepy, but needed to be here. Chidi, can you hear me? Let Chidi do stuff. Alright, just give me a minute. Okay, I can't find it straight up, so let me just go online. I'm going to type IntelliJ. So we go to the IntelliJ website. Let me reload it. Okay. Yes, I can hear you. How are you? Good morning. Oh, good. Yeah, good midnight. Welcome to the training. Okay. I think the IntelliJ website is down. I don't seem to be able to get to it. Download IntelliJ. Sorry guys, I just wanna quickly see if I can get to the site. Okay, I think there's something wrong with the website. Download. Do we have any other links? No. Okay, so what you could do to follow along, just because IntelliJ is not working. So what I would encourage you to do is, if we have to write code, you have to use a website to run your code. So I'm just going to type in Java code pen. So you can actually write your programs online. So we have all of this Java. Let me see. Oh, sorry, Java online playground. Online playground. Let me see. Yeah, so you can actually use ones like this, but let me get you a better one that is even nicer. Yeah. So here, these are online. It's just like IntelliJ, but very limited. But you can run your codes here. So you see something simple like system.out.println. I'll say hello world. So if I run this code now by clicking on the run button, you'd see it will print the results on the right hand side. So Goswell, I'm gonna paste this link in the chat now. Sorry, let me just. So you can use this website for now to run code if you want to follow along. Let me paste it in the chat. I'm going to paste in the chat of this particular meeting, and I'm also going to paste it on the WhatsApp group. So this is because you don't have IntelliJ installed yet. So I'm gonna get you the link for installing IntelliJ. All right, so back to the regular scheduled program. So good one. This is Java, and yes, we are a little bit ahead. I have the videos online. I think I sent you the link to the videos. You can try to catch up. Please, follow the program. Yeah, you have to do a little bit of catching up. If not, you're gonna really get lost. So, but for now, just follow along. Try to grasp as much as you can, and we'll meet up. So we're just going through the assignments for now. So I just want to really scan through it so that we can get to the regular scheduled program. So this is an age calculator for Constance. So if I run Constance version, it says, "Hello user, how old are you?" I say I am, let's say I'm 41. Then it tells me, this is pretty cool. It says you were born in 1983. You'll be 100 years old in 2083. So if I look at the question, also we see that it's correct. I said write a program that takes that's this one. Write the program that takes the age of a user. The program output should be the year the user was born and the year the user will become in 100 years. So you see, it's rightly said in 2083 I'll be 100 years, and rightly guessed my age, which is awesome. And I find the code to also be very clean, very user friendly. It says hello users greeting me, which is nice. I like that. It's quite user friendly. Is there something else I can pick from this for feedback? Yeah, I think it's a pretty clean program. Yeah, so we'll go to the next one, which is the second program. And the second program is write a program that takes the birth year of a person and calculates the age of the person by 2025. So if I say it's actually asking me what's your birth year. So I say okay, 1983, and it says in 2025 you will be 42. So the calculation is accurate, very nice, spot on. I think is beautiful, very nice. I'll move to IFAI solution for this. So I'll run the age calculator first, which is the same problem. So it says enter your birth year, also quite user friendly in terms of question. I'll say my birth year, I would say my birth year is 1987. It says in 2025 I will be 38 years, which is spot on, very correct. And I'm going to run the other one. It says please enter your current age. I'm going to say 37, and I push enter. It says your birth year is 1987. Your age in 100 years will be 137. Now if I think the solution is good, but I think you made quite a little calculation mistake here. And what calculation mistake did you make? So I see that you were adding the age to 100 years, and that's wrong because this will give you a wrong solution. What you should have added was your birth year. So remember here you said 2024, which is this year that we are in, minus age will give you my birth year, and then you have to add the birth year. So this will give you 1987, which is what I entered here. It will give you 1987, and 1987 plus 100 years will tell you my age. My age in 100 years or something. Oh no. No, sorry. I think you kind of like it's kind of like okay, you solved it a different way. This is not actually the answer because what I would like to know is the year I would become 100 years. So I think you kind of like you kind of played it around. So if you're taking the birth year and added 100 years to that birth year, it will tell you what year I'll become 100 years. So I'm just gonna take this one now, put it here, and say something like, I think if I run this now, I get close to what I mean. So my age is I'll say 37. So it says 1987. I was born in 1987, and in 2087 I'll be 100 years. So that's just the twist a bit, but very nice solution. I think you were pretty close to it. Did you get that feedback? Is Ifeanyi still here? No, Ifeanyi is not here. Ifeanyi. think his connection went off. Okay, so I'll give that to him later. I didn't notice it was there. So we'll move to OB. Uh, so OB's first age by 25. So let's see, we run that. It says please enter your first name. So this is also pretty interesting. OB is asking for first name, and now he's using the name I entered to ask me a question, which is welcome Darlington. What year were you born? Beautiful. I like this. Quite user friendly. I say okay. I was born 1987, and the program says by 2025 you'll be 38, and it completes. Very beautiful. Like what I like about this is he played around with variables again, user friendly, all of that. And I'm also happy OB used short as a data type. Remember, short does not take a lot of space in the memory, and he did something interesting here. So if I look at, let me look at his choice of variable, right? So here he used he got the birth year using short. Let's see, birth year using short. Okay, so being the fact that birth year kind of perfectly fits in short, and he did something we call typecasting. We're going to look at this. So he, when he subtracted this from birth year, he now converted it to, or made sure it's of type short. So this is typecasting. We're going to look at this in the future, but I see it's quite interesting playing around with the user friendliness of it. And we're going to run the second one. And it says please enter your first name. I'm going to say Darlington, and it says welcome Darlington, what is your age? I'll say I am 37. Let's see, I'm 37. And then it says Darlington, you were born in 1988, and you will become 100 years of age at 2088. Very user friendly, but I think the calculation is a little bit off. So let's take a look at this. I think the calculation is a little bit off. Let me just be sure of that. So this is 2024 minus 1987. So I'm 37 years old. So since I said I'm 37 years old, what I expected to give me is the age of 1987 as my birth year. So I think your calculation is off by 1 year. So yeah, so I would say look at the calculation. I don't want to spend too much time in that, but you can see it's pretty close. I think your math is just a little bit off when you look at that. But very user friendly, great. So let's look at Sumbor's version of age calculator. So I'm gonna run that, and let's see what she's got. So she says enter the year you were born. Okay, I was born in say 1983. Oh, sorry, yeah, 1983. Enter. It says you'll be 42 years old in 2025. Very accurate. But you see, Sumbo combined both programs together, which is also quite interesting. And he says, what is your current age? I say my current age is 41. And I push enter. He says you were born in the year 1983. Very accurate, because you see here that's exactly what I did. And you will be 100 years old in the year 2083. So this is also quite beautiful because it's very user friendly. It's combining variables, making it, taking things I filled in before, using it to put out as the output. And so I think that is really, really nice and awesome. So let me see. Let me just use the last few minutes because I don't want to make Chino so sad. Chinoso's like, yo, I sent him my assignment. So let's just also look at it. Just give me a minute. I'm going to download it and see if we can add it to, and also see Chinoso's solution. Just give me a minute. I'm about to get it out. Okay. So I have Chinoso's assignment being downloaded here. So I'm just going to extract it. So this is Chinoso's age calculator. I'm just going to take the code only. I'm going to take it and put it in her folder here. I'm just going to drag it. I'm throwing it here. Refactor. Take a look at it and now create. I'm just going to clean it up and then we run it. So let's run this. So yeah, Chinozo says hi, enter your name. Also greeting, very nice, quite user friendly. So I'll say my name is Darlington. Enter your birth year. I'll say my birth year is 1987. But yes, 1987, and it says, "Hi, Darlington. In 2025, you will be 38 years old." Very nice. I like also playing around with variables. Very interesting. Also very user friendly. Then it says, "Enter your age." I'm gonna say, "Okay, I am 37," and I push enter, and it says, "Hi, Darlington. You were born in 1987," so the calculation is correct here, and in 21, 24, you will become 100. 21, 24, you become 100 years old. So yeah, I think that's very nice, very user friendly, and again, you can see everybody is giving their own version of the solution, and that's what makes it beautiful. And also remember, it's not there are different ways to solve a problem in programming, just like in math. There's just different ways to do it, but the beauty of it is, yeah, it's learning from each other's own way of solving stuff. So that's beautiful. That's beautiful. All right. So I want to really commend you guys. Honestly, I enjoyed looking at through your codes, and I thought you guys did amazing. I mean, judging from the fact that that was our second class, I think you guys learned a lot. Honestly. So I also promised to. So let me see, how much time do I have? Last time I also promised to fix an issue we had in the code where I was not able to run Chinoso's code directly without using IntelliJ. So if I try to look for that code again, let me see. I think I had that code somewhere. Let me see. Just give me a minute. Where was it again? I have to look for it real quick. Documents. I think it's TechCodePractice code. Let's see. TechCodePractice. Yeah. Alright, but no problem. I'm gonna get to it because I have to explain something to you guys. So I have this diagram here. I think I sent it in the group app. And it's very important for you guys to know what's actually happening in Java. Very, very important. This is also something you might also see in interview questions, because it's very important to understand how Java actually works under the hood. Now, first of all, the question you want to ask is, what language does the computer understand? What language does the computer understand? And when I mean computer, your current Windows that you're working on, your Mac OS, what does it understand? Now your Mac OS and your Mac computer understands what we call machine code. So let's type machine code. Let's look at how it looks like. So image, let's see. So this is machine code here. This is an example of machine code. You see it? 011111. This is also 01. You see all of this. This is machine code. How many of you understand this 0111? If you understand it, please raise your hand. If you understand this, can you read it? No, you cannot, because the only thing that can understand this code is a machine. So if only a machine can understand this code, how can we now write programs? It's going to be crazy. I mean, that means you need some kind of calculator to be writing your programs, or you need to be a super genius for you to understand this. So how is it possible for us then to give computer instructions? Now, that is where programming languages come into place, because programming languages ultimately make it possible for humans to write code in a readable format, or in a format that we can understand as humans, and then something has to be responsible for converting it into machine code. So Java, what makes Java very interesting is when you write your code. I'm just going to describe the whole thing that happens, the whole process that happens when you write code. So this is you here. You write this Hello World application. When you write it, Java has there's another software that is attached to your Java development environment, or this your JDK, or whenever you install Java on your computer for development. It's called a Java compiler. Now, what does Java compiler do? Java compiler takes this English word that you wrote, because all of this is English. It's like you're talking to the computer in English. Public is an English word, class is an English word, hello is an English word. All of this is just plain text and a couple of numbers, right? And what happens is whenever you push the play button here. So you see when we're done, we push this play button here. What happens is IntelliJ does some work for you, and what it does is it calls or runs something we call the Java compiler. Now what the Java compiler does, which is this red stuff here, is it takes this code that you've written and compiles it. Compiles it means it just kind of rewrites it into a language that a software called JVM can understand. JVM means Java Virtual Environment. Now JVM, when you installed IntelliJ or when you installed Java directly, JVM directly gets installed in your computer. If you also want to know if JVM is installed in your computer, just go to command prompt. If you go to command prompt and you just type Java, you see something like this. Something will just pop up like this, like information. This shows that you have Java or JVM installed in your computer. Now Java Virtual Environment is just like saying you installed an app on your computer. Java is actually an app, a software, and what that software does is that software can understand bytecodes, because when you when you push that play button, it takes your code, it compiles it to what you call bytecodes, and the only guy that can read bytecodes is the JVM, which is like an app. You can compare it to an app on your computer, on your phone, but this time the app is on your computer. Now this JVM can read this bytecode, and whenever a bytecode is created, it's being renamed. You know, your Java class is normally called given a name .java, right? Like this is hello.java. But when it gets compiled, it creates a file that is called the same name of your class, but this time it ends with .class. We're going to see an example of that. Now this bytecode, when it gets converted, JVM can then read it, and JVM now takes this bytecode and rewrites it to machine language. And then your computer is now like, aha, now I understand what that human was writing. Now I know what to do. So this is the whole process that happens whenever we click on this button. So we do this, click run. All of that happens really fast. Because without this process, we would have to write machine code for us to be able to talk to the computer or instruct the computer on what to do. Now, how does this relate to the problem we had with Chinonso's work, right? So let's take a look. Let's go back to the code and let me look for that. So I'm going to go back to Chinonso's code, because ordinarily we can run it from IntelliJ, but we could not run it the other day directly from the computer. So I'm just going to go to my email and get the code again. So I'll say none. So let's look for it. I think it should be let me see, it's not currency converter. I think it should be this one. Alright, let's see. Okay, types of variables. Alright, let's get it. So I'm gonna download it. Alright, just gonna call it console 2. We're gonna open it up. Let's go here. So this information I'm giving you is quite important, huh? Because you might get questions like this during your interviews. So we're gonna go into Java. Oh yes, I remember. So this was Chinonso's solution, right? Chinonso had a solution like this, and what we did was we broke the solution down into different parts so that we could be able to run it. So let me see. I think we had that also somewhere in here. Just give me a minute, because we rewrote it, right? Because I was saying that Chinonso tried to solve it, the problem using objects for that. So let's see. think that should be somewhere around. Yeah, okay. I can find it. So let's just do that again. So this is Chinonso's. This was Chinonso's original solution. So Chinonso had this thing where she put class in a class. Remember last time it was like, oh, you kind of nested everything, and we started pulling it out, right? So we're gonna pull it out real quick. This is very important for us to understand this process. So I'm just gonna get rid of. This is not necessary. So we're gonna start creating it. We're gonna start refactoring it. So I'm gonna create a class called engine.java. I'm just going to create text, call it engine.java, delete it, enter, and we'll take this engine class. Yeah, okay, go ahead. All right, send it. Can you send it right now? Okay, send it. Let me just pull it up again. All right, so Chino's just trying to save me some time. That's good. So I'm gonna stash this and call it ongoing. So we pull up Chino's version. Gosby, did you have a question as well? I saw your hand up. Yeah, did you have a question? Okay. Alright, no, so did you send it already? Alright, so let's see, kind of, see if we can get it. Alright, so this is it. Alright, thank you. We'll just go and get it. This is very important, huh? So it's not a bad thing that we are spending time for me to explain this. So we're gonna pull this out. So the thing there, if you remember, let me see what was in here again. Okay, so this has nothing to do with us. This is not our business. I'm gonna get rid of this main, and I think I expect to find a main in here. Get rid of this one. Get rid of this guy. So let me see. I expect to find the main in data type of variables, and that is exactly what I see here. So fine. So the point is, let's look at what's going on here. I told you guys last time, if you want to run your Java code, you can run it with the command prompt. So I'm just gonna type command here, and doing that, it opens this prompt, and of course you see my command prompt is pointing exactly to this location where I'm at, right? So now I'm trying to run this code. I'm not using IntelliJ. I just want to run it directly from here. The problem is when I try to run it, now again, the code that you use to run it is Java, and then the name of the class where you can find the main method. So this is the name of the class we can find the main method. That's this guy, data type variable. So we just paste that there. But when we run it, it's telling us it cannot find the main class. And it's like, what does this mean? Now remember, I told you guys that, let's go back to that diagram. So I have my code in there, and I'm trying to run it. That means I'm already here, I'm here. I'm saying Java Virtual Machine should run this code. But technically what it's saying to me is, I can't find any bytecode. I don't understand this. This doesn't make sense to me. I need something I can read. So that means there's a step we are forgetting. And that is the step that IntelliJ does for you. But since we're running it directly, which is we want to run it directly from this folder without using IntelliJ, we have to do the intermediate work ourselves. And how do you do that? You do that by compiling the code first. That means we have to perform this task first ourselves. Since we're not using IntelliJ, we have to compile this code or all the code into a class file so that it becomes a bytecode. And how do you do that? You have a Java code for that. You say Java C. Java C means Java compile. Then we say compile asterisk .java. Asterisk means compile everything in this folder. Everything in this folder that ends with .java. So don't forget, it's different from running it. When we were running it, we run with Java. When we are compiling, because we have to compile to change it into bytecode so that JVM can understand it. So now let's do that and see what's going to happen. So I'm going to push enter. And let's see what's going on. Computer's frozen. Alright. Let me try that again. Java. Oh, sorry. Java. Okay, Java. Asterisk is Java. Good. So it has run, which is what you see. So it ran, it didn't give me any error. Now look at my folder, what happened. Did you see now that every class that was Java now got a .class file created? Now that's exactly what we had here. You see, I told you that every class.java will be converted into bytecode. Now let's see what bytecode looks like. So remember, this is, yeah? Alright, shoot. Yeah. The asterisk is a way of saying, remember, I'm in a certain folder. I'm actually at this folder here. You see, this is the folder, this is the path I'm at. Sorry, this is the wrong place. But if you see, I'm at tricks, download, blah, 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 all the way to source, right? That's exactly where this is pointing to my command. I'm saying that I'm actually in the same map. The asterisk means in this map where I am, look for every file in there. Then when you say asterisk.java, so I'm saying look for every file that ends with .java. So I'm going to delete all of these class files again. I'm going to delete everything. So it becomes clear. See, everything in here ends with .java. So the asterisk means in this folder where I'm at, then look for everything that ends with .java. And you see everything here ends with .java. And then the Java C means Java compile. That means compile everything you find that ends with .java. So we'll do that again. And you see it creates all of these class files for us. Now remember this was how the data variable looks like. This was what Chinoso wrote in the data type variable. See, we can read this. This is what we did last time. But when it gets converted to bytecode, look at how it looks like. If I open this now, do you see this? You cannot read this. The only thing that can read this is what? Please understand, is the Java virtual machine. And the Java virtual machine can then take this bytecode that you're seeing here and then convert it to machine code and then use it to talk to the computer. So you see now, we're going to run this code again now. So now we're going to say Java space. We use the name of the class where the main method is at. So Java, because now we want to run it. Remember, we now have our bytecode. So I'm going to right click. I'm just going to type it there. Wait, let me use dir. Okay, so I'll say Java, then data. So instead of .class, you just have to say Java. If you want to run it, you say Java and then just the name of the class that has the main method. So you see here now we have two of this class, but we are interested now in the class, but we don't put any .class. We just call only the first name, and then Java knows that now it has to read the bytecode. So if we press enter, you see it gives us the results we are looking for, which is the assignment we did last week. Now, why is this then different, or how does this look in IntelliJ? So remember, we are doing this because we want to run it directly from the folder, and we want to and we want to run it, and we're not using IntelliJ, right? But let's look at what IntelliJ is doing actually. So we go back to IntelliJ. So we just pick one of the ones we just did. So you see, IntelliJ actually has this code structure. You see, it has IDE, out, source, and some other stuff, right? Now, what IntelliJ actually does is, if you open this file now, you'll be like, huh, okay, Darlington, right now we saw a class folder, we saw all those classes, we saw the bytecodes. How come we're not seeing that in here? What's going on? What kind of magic, what kind of sorcery is IntelliJ doing? Well, IntelliJ is not performing any sorcery. The only cool thing is IntelliJ is organizing it in such a way that your class, your bytecodes is not in the same folder as your Java code. And that's why when you click on this out, or more or less we have to go into, let me see. So we have to go out of here. Let me see if I can find the location. Let me put my mouse over here. So we see this is found in document, TechCodePractice, Java, TCP. Okay, let me go look for that in my computer. So it was a document, TechCodePractice. So I'm trying to find the location of this file, right? So let's see. Or let me open one of the ones we just ran. So I'm gonna open, say, this one. So it's source code. Just close all tabs, open this. So where is this? This is in TechCodePractice code Java TCP. Okay, I'm gonna look for it. TechCodePractice code. What was that again? Java. So yeah, Java TCP first example. Superhero. So let's see. Superhero assignment 2. Assignment 2 students. Let's see. So let's go one level up, because at this point now we are in good. So if I go a little bit higher now, right? So you see here at this level, this is what you're seeing here. This is what IntelliJ is showing you here. So that's it. Source, output, you see? IDE, output, source. That's exactly what you're seeing here, right? But the question is, where is my bytecode? Because I just run this, but what IntelliJ is doing is it's keeping the bytecode in a separate folder called out. So it does create it for you. So let's look for the bytecode. So we go in here, production, superhero. So you see one of the bytecodes is even here, but that's for a different one. But let's go to Chinonso's own bytecode. So we see we have Chinonso, I see. This is the bytecode for this age calculator class, .java. So it creates this bytecode so that when you now click on this run, what it actually does is it goes out there and runs that bytecode. And the reason it knows where to look for the bytecode, the reason why it knows it has to go all the way into this out, is because in the configuration here, in this IML file and in this IDE files that we have here, which you don't need to look at, IntelliJ has already configured it in such a way that when you run it, it knows where to go find it. You understand? So that's why IntelliJ organizes it for you that way. Goswin has a question. Yes, that is the extension. That's what you have here. I also said your class normally ends with .java, but when you compile it, it creates a class and ends it with the extension .class. You understand? So please memorize this cycle, and this is what makes Java very powerful. Java has what you call virtual machine, and virtual machine can run on any computer. It can run on your phone, it can run on your computer, it can run on Linux, it can run on MacBook. This is something that makes Java very powerful. This is why it's beating all other languages, because it can run everywhere and anywhere. And the reason it can run everywhere and anywhere is because of this Java virtual machine. This Java virtual machine is what takes whatever code you wrote here, and it can run it. It can use it to translate to a machine language that a device can understand. So even this hello world we are writing right now, we can take this hello world, put it on your phone that is not a computer. As long as a JVM is installed on your phone, it will print hello world on your phone. You don't need to learn a different language. So that's why we say we call Java build once, run anywhere. because of this Java virtual machine. But this is the life cycle. This is the process. Very good thing for you to remember. Now, before I proceed, do you have any questions? Chinoso, shoot. Okay. So the question, so, so the question, okay, did you compile your code first? Remember I said you have to compile your code into bytecode. Okay, so share your screen and let's see how you compile your code. We just take 2 minutes for this because this is very important stuff for you guys to remember. So can you run the code that showed that you compiled it? Can you run it? Yeah. Yeah, just type it. Just do it. Yeah. So I can tell you what to type. Just type Java. Okay, before you type Java, right? I would like to, before you type Java, I would like to know what's in this current folder where you at. So just type ls and press enter. So just press ls. ls actually is a prompt command to tell your command prompt show me what's in this folder. So as I look at this folder, I don't see any of your Java classes here. So you're already at the wrong place. So first of all, you have to go to the right place. So can you do you know where you saved your file? So where did you save your file? Okay, so I can see, but you're not in there. You just typed it. So to go in there, you have to type cd user. So you have to go in one by one, right? So if you type cd space users, let's see what happens. I think it's users with an S. Let's see if it goes in there. So you see it doesn't go in there. That means you're also not in the right place. So I want you to type, let's see, because if you look at when you did ls, I also am not seeing a users folder in here. You get it? So you have to go to the right place. So if you type cd dot dots, let's see where it takes you to. Cd dot dots. So let's go one level back and press enter, and then go. Okay, you don't have anything there. So you have to find how to get to this exact location where it's pointing at. And let me see. I'm not an avid user of Mac, but I do have an idea how you get here. So what's gonna happen is I'm gonna call you up and I'm gonna show you how to get this. But the reason why it's not working is you're not actually in that folder. So that's why. So I'm gonna call you separately and we're gonna do that. So it's quite simple. Alright, so back to the regular scheduled program. Or is there any other question? Sorry I took some time on this, but this is very important stuff. And that's the beauty of having this kind of problems, because it also helps us to expand on other issues. Now let's go to the next part. So one of the things I want to also explain to you guys, for you guys to understand, is I try to chip in words and phrases that I know you hear a lot in the Java community, and even in programming, people that are programmers, you hear these terms a lot. It's good you know what they mean. And remember, I also told you guys I'm going to let you guys know what expressions are. So this is something I cut out from the book I shared with you guys on the WhatsApp, because it's good to know what the difference is between a statement and an expression. Because when people are talking as programmers, they use this word. Oh, I wrote a statement. I wrote an expression. You need to know what that is. And since you guys have been writing code for a while now, it's good you guys know what this terms means. When someone says it, what are they talking about? And when you say it, what do you mean? So what is a statement? Now, a statement in Java, or in basically every language, is when you write a line of code that actually doesn't do, how would I put it? It doesn't really do something. It doesn't give you. It doesn't create anything. It's just like for example, you see in the example there. It's when you say in size equal to 5. That is a statement. That is more like you're stating a fact. You're like, okay, size is equal to 5, right? Then an expression actually produces something. It produces a value. It actually does something. It produces a result. And that's why when you look under, you see you have a command that says new object. That actually does something. It creates a new instance of an object. When you say map.sign is blah blah blah, it performs an action. So that is an expression. So a lot of times you might see these words bubble up. You don't have to cram it. You don't have to, how would I say? You don't have to remember it all the time. But when someone uses it in a phrase, or when you are communicating with your fellow programmers, and someone is like, "Yo, I wrote that expression here. I wrote that statement here." You just have to like understand what they're trying to say. So basically, a statement is what you guys have been writing all this while. So if I look at your codes, I'm going to pick up one of the codes, you guys. So this is a this is a statement. This is a statement. This is a statement, and this is yeah. This is let me see. We have an expression here. So this, for example, is an expression because this when you click on this, I mean when you run this, it actually creates a new object of buffer reader. So it does something. Do you understand? But this is just a statement. This is just saying, okay, I'm creating a variable. I'm creating a variable. So I want to put this out there so at least you would have heard of it. You would have heard some form of explanation for it. It will be at the back of your mind. It probably will not come up all the time, but when you're solving problems in Java, you might hear these words come up like, oh, write a statement or write an expression. Then you can always, refer back to your notes or try to understand what they're saying. So I just wanted to put that out there. Now let's go to the exciting part, which is loops. Now, who has heard of the word loops? And I'm not talking about Fruity Loops. If you've heard about the word loop, please raise up your hand. Okay, I'm going to ask Mr. Chidi. Mr. Chidi, please tell us when you first heard of loops, what comes into your head? Like before you even touch programming or whatever, what was the first thing it made you think about, or what did you have in mind when you heard the word loops? Exactly. So it's beautiful because I'm sure you saying that it's actually because you just know it as an English word. So which is good because if you know that the name actually comes from like English language, a loop is just something that just repeats itself. So that already is bringing us halfway. Loop means repetition. You just keep looping. It's a basic English word before you even start coming into programming. And that's exactly what you see on the screen. It says loop in Java or in any programming language. When you use the word loop, it means repeating a code or a block of code until a specific condition is met. So who can give me an example of loops in your life? Have you guys done anything that was looping in your life so that we can bring it to real life? Has there been? I have an example, but I want to hear you guys. Have you guys done anything that was a loop and something had to happen before you stopped looping? Who has an example? Raise up your hand, please. Joy. Oh, Joy is in the group. Joy, please give us an example of your loop. I can't hear you, Joy. I think. Very good example of a loop. Very good example. So, wait. That's a good one. So, what has to happen before you stop looping this whole waking up thing? That die, I mean, you gotta die before you stop looping or waking up. So, no, it's a good example, but I want you to think about it like that. Does anyone have another example of in your life that is a loop and something has to happen before the loop ends? Come on, we have a lot of this. Constance, shoot, what's your own loop? Okay, so what stops it? What is the catalyst that stops, that makes you stop it? So you get tired, right? So you say, replay this music until I get tired, until I press stop. That's it. Great, that's a great example. Does anyone have another example of a loop in their own life? Okay, I'm going to tell you my own example, right? So when I was a kid, we used to fetch water to fill up a drum. I hated that stuff. We have to go all the way outside to the well, fill up a bucket of water, and bring it all the way in. And we have to continue doing that thing over and over again. And the only catalyst that stops that loop is the drum has to be full. So as long as the drum is not full, we have to keep looping and looping and fetching water and fetching water, fetching water until it's full. So that is a real world example of how a loop works. So if you think about it, a loop is a task you have to repeat, and there must be a catalyst that will make it stop. Without the catalyst, what will happen? Can you guys tell me? Without a catalyst to stop, what happens? Raise up your hand if you know. If I That's it. So you see, I'm sure that's why we have death. Because if not, we will wake up for thousands of years. Okay, I'm just kidding. But that's what you call an infinite loop. You loop and loop and loop and loop and loop and loop and loop. I mean, and loop. Imagine if even another loop we have is sleeping and waking up, right? So imagine we don't have a catalyst to sleep. You'll be awake. Your loop of being awake will go on so long until one day your brain will just explode. So there must be a catalyst for stopping a loop. That same concept is exactly the same concept in programming. If you write a loop without a catalyst that will break it out of the loop, it will continue to run, and your computer will continue to run that cycle. And when it keeps running that cycle, what happens is that your memory, the memory of your computer, keeps getting bigger and bigger and bigger. Before you know, your computer will crash. So when you're writing loops are actually very powerful. You cannot do without them in programming. It's just impossible. But you have to understand the structure. Now there are different ways of writing a loop, right? So I'm going to go to the next page. So there are different structures of loop. There are different ways to write loop, which are very popular, even across multiple programming languages. We have the while loop, which we're going to see very soon. That's the name, the while loop. So if someone says the while loop, you guys are going to see that. We have the do while loop. You're going to see that. These are the names they call it, and they are very similar to how they are written. Then you have the for loop. So these are the three basic loops we have. Now what you see under there where I say continue and break, these are ways to jump out of a loop. So like Joy gave a very interesting example. She says she keeps looping over a job. So take for example, Joy is like, okay, I got this job. I don't really like it. I hate it. But because I want to make ends meet, I want to be able to pay for this my house that I'm living in. I reckon I'm going to loop this job for 10 years. I have no choice. I hate it. But I'm going to just loop it because if not, I can't pay my bills, right? So Joy is looping over this job. And guess what? While she was looping over this job, she was taking a course called Java. And then her mind is, I'm going to do this 10 years. She's already registered. I'm going to do this crazy job for 10 years. But she's studying Java. And then she's good at Java. And all of a sudden, she gets a job offer to go work in a company where they use Java. But remember, her original plan was to work 10 years. Now, what she has to do now is she has to break out of that loop. She has to say, I'm done. So she doesn't even have to wait for 10 years to come. She can jump out of the loop and go do her Java job. Now, in programming, we have stuff for that, and that's this break. We use the keyword break. We're going to see how this works anyway. But I'm just trying to bring the concept into real world for you to see see why those things are there. Because, programming makes the real world in a lot of ways. Now the while loop, what is the syntax? Now for those that have been programming a lot, this might be a little bit um, similar. The while loop might be similar. There are some programming languages that have it and some don't in terms of syntax. But this is how it looks like in its raw form. We're going to go deeper, right? So basically, you use the keyword while. So once you use while, Java is like, okay, I'm ready for this running. I'm ready for this loop. Then you give a condition. This condition is the condition that has to be met for it to go into this block of code and run. So this condition, this block here only results in a true or false condition. So it's a boolean. Remember in our last class we talked about the data type boolean. It returns a true or false. As long as this boolean is true, it will continue to loop. And when it turns false, it will stop. It will jump out of the loop. Now let's dig deeper because this is just more of a skeleton of how it looks like. So I'm going to go to the next part, and this is an example of how it looks like. So I have a question here that says, make your Java program print, I will do my best in school 100 times. For those of us that went to Ajepako school, you understand, in Nigeria, we know this problem. When you, I know we have some Ajebo here, but those of us that went to Ajepako school, I remember when I was in GS1, I did not participate in whatever was participated on. But the teacher said the principal said we had to write something in the lines of, I will never do this again, and I will be serious with my school or whatever. We have to write down, I don't know, was it 5 or 10,000 times on a piece of paper. We have to just keep repeating, I will not do this again, I will do my best, or something along those lines. We just have to write it for 10,000 times, the same thing. And I remember I mobilized my sisters. I'm like, you guys help me, because they were waiting to beat the crap out of us if we don't come with a whole full scap of paper, multiple full scap of paper, with the exact same sentence. You get it? And that is just crazy, because at the end of the day, teachers didn't even look at it, didn't do anything with it. But it was something of a loop. We had to repeat that sentence. Now imagine if you could use a computer to do that. And that is where while loop excels. And that is also the problem we're having in the screen, because I'm also giving the computer that same punishment, and I'm saying, I want you to print, I will do my best in school 100 times. Now, if you want to use a while loop to do that, that's what we see on the screen here. Very simple. First of all, you have to tell the computer what is the starting point. From what number do you want me to start counting? So that's why you see out here we created a variable called counter. Remember, a variable, you can name it whatever you want. I gave it of the type integer. That makes sense. The type integer. Of course, you can use, since we are counting 100 times, you can use a much more smaller data type. But integer is fine. So I said type integer, I want a counter. And the counter, I initialized it to 1. So for those that are new in the class, this is a data type. A data type is more like saying, I am telling the computer what I want to be saved inside this variable. What type of stuff do I want to be saved inside this variable? And int means int, or integer, sorry. So I'm saying I'm creating a variable called counter. It can only hold real numbers. Real numbers are numbers that doesn't have a decimal. You understand? I mean, I was already in university before I knew what real numbers was, so I'm not even that smart in math. But integers are numbers that don't have decimals or real numbers. Then I'm saying I want to initialize this my counter to 1. Then we start our while loop. So remember I told you this block always has to return a boolean true or false. And as long as it's true, it will continue to loop. So the question now is, I now say, okay, now I'm ready to write this block of text that I said. And I wrote, while counter, which is my variable here, while counter is less than or equal to 100, you can go into this block. So at this first run, right, you see when it tests this condition, at this point counter is equal to 1. So if counter is equal to 1, that means this is true because counter is less than 100 and it's not equal to 100. So it's still less than 100. So that means it will print this. It will do it again. Okay, it will print this. Then here, this is a notation that probably is new to you guys. I haven't shown you guys. This is what we call an increment. An increment. That means take whatever value is inside counter and add 1 to it. This is exactly the same thing as writing this line of code. I'm going to rewrite it. So this is exactly the same as saying counter, which is this guy up here, is equal to counter. That means in this variable counter, take whatever is inside counter and add 1 to it. This is exactly the same thing, but we have a shorthand for that. A shorthand for that is just saying, doing something like this, counter plus plus. So these two lines are doing exactly the same thing. So let me take this one out just to make this a little bit readable for you guys. So that means when it prints this the first time, it will loop again, and this time when it gets here, can you guys tell me, after it has done this the first time, can you guys tell me what the value in counter will now be? So let's try Chinos. So Chinos, can you tell me what will now be the value of counter? Exactly. And why would it be 2? Sumba, can you tell me why would it be 2? Exactly. So there is an increment that's happening. So 1 was added to it, so it's become 2, it's become 3, and each time it's printing this until this condition returns a false. And when the condition returns a false, it breaks out of it and continues running your code. Now let's see this in real life, right? So let's go to our code again. We're gonna create. Let's run this exactly how we just said it. So we have Chidi raising up his hand. Chidi, can you ask your question? Yes, but if it's equal to 100, that means it will also print this guy. We're gonna see what I see where you're going with this, but we're gonna test it out and see exactly. That means it's gonna print this out, then it will loop again. But when it loop again, then it's what number then? What would it now be? 101. 101. And when it's in 101, it will return false. It will break out. So we see this in action, right? So for those of you who are new here, one of the rules of writing Java, in case, for those, for Gospel, we probably don't need to do this, but if you want to write your Java class, first of all, your class name needs to be exactly the same name as your class name. So you see, I have superhero here. The name of my file is called superhero.java. Your class all has to end with .java. But if you are using IntelliJ, just right-click on your source code, click on New Java class. So let me just do that. I'm gonna use a different stuff. So I'm just gonna do that. So let's do New Java class. I'm gonna say while loop test. So this is the name I'm giving my class. So if I push enter, you see I get a class called while loop test. And you see the name of my class is the same as the name of my file. It also starts with public class while loop. Now inside the while loop, you have to have a main method. The main method is the door to your program. Without the main method, your program, Java would not know where to start running your program. So you have to have what you call a main method. So the syntax for main method is like this. You say public static void main in small letters because Java is case sensitive. So you say public static main void main string and then args. So as long as you have this, you have told Java this is the door. This is where you can start running my program. So this is just for a lot of us already know this. So now let's practice our do while loop. Remember, I'm punishing the computer. I'm telling the computer you have to print. What are you going to print again? I will do my best in school 100 times. So let's do that. So we're going to say, first of all, we're going to give an integer of counter, create a variable called counter, and we're going to say it starts from 1, and then we say while, now a boolean comes in here, so as long as counter is less than or equal to 100, I want you to print this is how you print actually, we use system.out.println, and we say we print that text, which is the punishment, and I have a typo here, system, and that is what it's going to do. Now remember, if here I put my increment here, right? So let's give this a shot and see. So we have our play button here. When we run this, let's see what happens. So you see it prints, it kept looping. I would do my best in school a total of 100 times. But even at that, we are not even sure if it's 100 because I can't start counting this, right? It's crazy. I mean, counting this, I mean, Chidi might be like, I don't know, it might be a little bit over 100, it might be 101. Down, please, it's too much because it's kind of critical. All right, which is a good thing actually. So we're gonna try to make us see how the numbers that come with it. So and that's very simple, remember. So we know the counter is here. All we just have to do is just add the counter here and say plus, right? So we want to show the number every time it prints. So we're saying this counter, print it out every time you're looping because you know it keeps incrementing, right? So that way we're going to be able to see it. So I'm just going to put a dash here also just to make it look pretty. So I'm going to stop. I'm going to run again. So now we're going to see the number, and you see the last one is actually 100. So you see it starts with 1 and it goes all the way to 100. So I mean, if I had this when I was in school, that punishment would have just taken me a few seconds. Even if I had to say a 5,000, I wanted to print this 5,000 times. Let's do that again. I just changed this to 5,000. Sorry, to 5,000. I run this and let's see. And you see, in no time we have 5,000 of these words printed in a loop because of a loop. It's a very powerful stuff. Now remember, without this increment and without this increment here, if I remove this increment, so using double slash, you see I put double slash. This is a way you comment out code. That means Java will not run this code, it will jump it, it will skip it. If I run this code now, it will loop forever. So let's give it a try. You see what's going on here? It just keeps printing, and it keeps printing 1. You see it's printing 1 1 1 1 because nothing is not incrementing the value, and this while loop is constantly true. Now imagine this is happening. My computer is going to crash at some point because this is using memory space, it's using disk space, it's just working. It's just like someone that's not slept in years. At some point you will crash. You understand? You will crash at some point. So we're going to break out of this by using that stop button. So you need a condition that's going to make it possible for this Boolean value to become false at some point. So this is how the loop works. Now we have also another variation of a loop called the do while loop. So they are like brothers and sisters. They work hand in hand. So let's look for that. So let's see. Chinonso, you have a question? Yes, there is, but you have to program that quite efficiently. So we do have okay, if I open my computer, right? So let me show you guys something. Let me see. Services. So a lot of you might not know how the computer works or like what's happening under the hood, right? So a lot of times you have applications that are running on your computer that makes stuff work, and a lot of these are called services. So you see, for example, your Bluetooth service. So your Bluetooth service is just okay. You can't see it on my screen right now, but a lot of times you turn on your Bluetooth service and it just keeps listening. Yeah, I think you have that on your phone. Whenever you turn on your Bluetooth service, right, it just keeps listening. So even in my computer here, you see I have a Bluetooth service here. It just keeps listening. It's just listening for signal. Anytime you turn on a Bluetooth device, it's I got you. It displays. So this kind of services are kind of services that you technically want to put in a loop, and the loop is keep listening for a Bluetooth device. But normally the way you probably would program this kind of listener is maybe listen every 10 seconds and wait for every 5 seconds. Just every 5 seconds listen. Every 5 seconds, but it's a loop. Because without that loop, you would not be able to actively see if a Bluetooth device is on. Do you understand? So there are instances, but this is carefully programmed in such a way it doesn't take up the whole disk space. But there are instances where you want an infinite loop, and this is one instance, listening to signals. If you write a program that listens to signals, there is a very high chance you might put it, depending on how you program it, but there's a very high chance you might put it in a loop, which is keep listening to signals, until the user says Bluetooth off. But as long as it's on, keep running a block of code that says listen to signals. Listen to signals. Is there a new signal? And if there's a new signal, catch it, put it on it, connect it, start using it. So that is probably a situation where you might need an infinite loop. But it's a choice that you have to do or make consciously. Right? But great question. Any other question? No. Alright. So I want to introduce another variant of the while loop, right? So the while loop has also a very interesting syntax that is very similar to our while loop. So remember, this one is called a while loop, and we have a do while loop. So this is another name: do while loop, while loop, do while loop. So do while loop, first of all, always executes a statement at least once before it jumps into the loop. So an example of how we can use a do while loop is I have a question here. So we have for input collection. So remember, take for example, we want to, how would I put it? So I would say, okay, let's convert our print 100 stuff. Let's convert it to a do while loop. So remember, a do while loop first has to execute a block of code before it jumps into the loop. So I'll just to make that clear, let me show you something. So what if I made this counter 5,000? I made this 5,001. What do you think is going to happen? Please raise up your hand. What do you think is going to happen? Oh no, this is not even 5,001. This should be 5,001. If I So you mean it to not get into the loop?
This is so great.
Constance, you agree with that? Because I saw you raise up your hand. Exactly. So let's test it. Let's see, just in case you guys are wrong. Okay. See, nothing actually happened because it tested this condition, and this condition was immediately false. So it's like, bro, I'm not looping stuff because the condition is false. So in instances like this is where you might want a do while loop. A do while loop is, I want to do something first before you enter the while loop. Now let's give it a shot. So a do while loop has quite a different syntax. So we're going to try to write a do while loop using the same question, but the question is now is, what do I want to do first? For example, I want to say, hello, how are you doing, before we start running the loop. I want to say that first. So a do while loop is just a very cheesy example anyway, but I just want to use it to make a point. So let's try that. I want to greet the user before I start looping. So that's just a thing. That's just why I'm using a do while loop. So a do while loop has a syntax like this, and then I think, let me first show that in the code. So it has a syntax like this: do, and then you put your statement here. Remember, I used the word statement. I explained to you guys what statement is. You put your statement, and then you loop for the Boolean condition. Right? So let's go into that again. So we'll do that. So I'm going to open up this integer as well. So this our counter is still valid for us. And then we now type while. Sorry, I type while. The same condition. I'll just use the same condition here. So please pay attention to the syntax, huh? Syntax is just slightly different. And now end this here. So in the while loop, you see after the while we have our curly braces and our statements inside of it. For the do while loop, it's a little bit of upside down. The curly braces is on top, and then you have the do on top. The do on the top of the while. And then at the end of the braces, you now have the while under. So I'm going to print the same thing up here. I'm going to take it, but this time I'm not putting it under the while loop. I'm putting it inside the do loop. I mean, inside the do actually. So what will happen is that this condition or this stuff will be run first. Oh, let's do something else. Let's see. So I want say we said we wanted to print welcome first, right? So we say system.out.println hello and welcome. So what is going to happen here is, so let's see. I'm just going to cut this. Oh no, we can just leave it there because we're trying to use the same code, right? So what's going to happen here is, if you look at it, because of the do while loop, will always run this do first before it tests the condition. It will always, please pick my words, it will always run this do first before it runs the condition, then go back again and run the do again. So that means when we run this code, it's going to run this, it's going to print this, it's going to increment this, and then when it comes here, it's going to be like, oh, this is false, I need to stop. Let's give that a try. So you see, that's exactly what happens. It came here and it says hello, and then it prints this out, because you see it's at 501. It prints that out, and it came down to the while loop and it's like, sorry, I can't go further because it's false. So if we take this counter back to 1, then let's see what happens. So I'm gonna run this again. Oh, sorry, that's a different stuff. So let's, well, actually it's the same thing. So you see, it actually runs perfectly if we go all the way to the top. So it says hello, welcome, and it runs 1 and then just keeps looping and looping again. So it's very rare you see someone using a do while loop, but it is there for you. So if you actually have to run something where you have a precondition, you have maybe the first thing needs to be run anyway, or something has to be done anyway before you start looping, a do while loop is your candidate. You understand? But in a lot of codes, you might not see it. Actually, I've never seen, since I've been working in a professional field, I've never seen do while loop in the field, honestly. But it is there. I would use it if I need it. Most people just go ahead with the while loop, but I just want you guys to know the syntax. You could get it in your exams, or you could get it in your test trainings. Just know that's what it does. So while loop, remember, while loop just goes ahead with your loop, tests the conditions, and just stops when it breaks out. A do while loop runs the statement first before it tests the condition of a while loop. So that's why you see it's kind of upside down. It does before it loops. That's why it's called a do while loop. Do first before you test the condition in the while loop. Right? Are there any questions? No questions. All right. So let's go back to the slide, and we have a lab exercise here, which is also something I would like to give you guys as an assignment. Now, remember, we're still going to talk about one more powerful loop, which is the for loop. But I want you guys to play around with do while loop already. And this is something I'm going to give you guys today to take home as an assignment. Now, what is the first assignment? Pretty easy. Write a Java program that prints out 1 to 10. Now, you know, without the power of the do while loop, remember, if I hadn't given you guys a training for this do while loop, I'm sure what some of you would have done is something like this. So remember, the question is, So remember the question is print 1 to, write a Java program that prints 1 to 10. Now you guys already know how to print, which is using your system.out.print. So you can just solve it by saying 1, make another one, you say 2, make another one, you say 3, make another one, say 4, 5, and so on, right? So if you run this probably also does the same thing. See, it prints 1, 2, 3, 4, 5. But imagine I want you to do 5,000. Imagine I wanted you to do 10,000. You can't do it like this. This is not efficient, and this is actually not what I want you guys to do. I want you guys to use the power of the while loop. Because imagine you're using a while loop for this, it's not even going to be more than 3 lines. Even if you have to print this 5,000 times, in 3 or 4 lines, or maybe maximum 5 lines, you'll be able to do this. So that's the first thing you want to do. Print 1 to 10. Please use a do while loop. You see, this is what I said. I said use a do, sorry, not a do while loop. I said use only while loop or do while loop. You can use whichever you feel you want to use for this, right? The second question is write a Java program that calculates the sum of the first 10 natural numbers. So what does that mean? Write a program that will calculate the sum of the first 10 natural numbers. So your program, also I want you to use a while loop. So your program should be able to count to add 1 plus 2 plus 3 plus 4 plus 5 all the way to 10, but using a while loop. Sorry. So the question is, how do you make it 2? How do you make it 3? How do you know what to add? Or you have to increment this somehow to get these values, right? So that's why I want you to use a do while loop. Of course, you can start adding it like this, but that's not what I want. I want you to, I keep saying do while loop. I need you to use either a while loop or a do while loop to get this done. Okay? If you have questions on this, you can ask me in a bit. So I'm just explaining the assignments, right? Assignment 3. Write a Java program that prompts the user to input a positive integer. It should then print the multiplication table of that number to 12. So I want you, the program should ask the user, okay, give me a number, and I'll say 4. The program should now print 2 times 1 is equal to 2. To 2, goes to the next one, say 2 times 2 is equal to 4. Just a basic multiplication table that we all know, but we're going to be using a loop. Now this is going to get your brain cringing and thinking, and especially if you've not done this before. For some that have done it before, it might be a lot easier, but you have to start thinking, how is this going to look like? How is this going to work? How am I going to use a loop to do this? You understand? So that's what this is about. At the end of the day, when I run it, it should give me a multiplication table till 12. So you see, I gave you guys when to break out of the loop. 12 is the breakout. This one, 10 is the breakout. This one, 10 is the breakout. So I want you to loop until you complete the table till 12. Then the fourth one is write a Java program that prompts the user to input a positive integer, very similar to this one. But it should then print the multiplication table of that number in reverse. So it should be starting from 12 to 1. So if it was this same one, it's a 2 times table, but instead of starting from 2 times 1, it will start from 2 times 12, and then the next one will be 2 times 11, all the way down to 1. So the breakout is 1 of your loop. Do you have any questions on this assignment? Okay, so first of all, for some people that are looking at this, it's like, oh my god, this is crazy. This is gonna blow my head off. Don't think about it like that. Remember, start with what you know. Follow the question and solve it step by step. At every step, you ask yourself a question of, what do I have to do here? Do I have to get an input? Do I have to put an input? Is there some small mathematics that needs to be done? You already know about the increment signs. So where's my, let me control Z this out. So you already know how to increment. So let me just get rid of this do while. Let's go back to our regular while loop. So you already know how to increment. If you put a double plus plus in front of your variable and the variable has to be an integer, if you put a double plus plus in front of it, it adds 1 to it. I also showed you guys a different way of writing this. It's the same thing as saying counter. So at this point now, let's change this to 1. So at this point now, counter is 1, right? So we are now reassigning the value of counter. We say counter now is equal to counter. So go and look for whatever value is in counter, take that value, add 1 to it, and store that in counter again. So now counter will be 2. So this is the same thing. So you see, if we run it now, it will do exactly the same thing. It prints to 5,000. You understand? So just know that this is the same thing as this. But I would encourage you guys to definitely, it's good you know it, but use this because you see this a lot in people's programs so that you start getting used to it. This is called an increment, and it only increments by 1. Take for example, you have a situation where you're like, no, I don't want to increment by 1, I want to increment by 2. Okay, then this will not work for you. Then you have to probably break it out and say, okay, I want to increment by 2, so you now say, okay, counter plus 2. Then this is different. Then you should write it like this. You get me? But since you're incrementing by only 1, then just make it easy for yourself and do this. So think about everything you know and start solving it one by one. Don't think about it as one big problem. Oh my God, a lot of things need to happen. I have to make times table. I have to do, oh my God, I quit. But make it more of, okay, what do I have to do first? What do I know? I know how to use the while loop. I know I need to have a breakout. What is my breakout? You put your breakout. Now start thinking logically. Programming is all about logic. You understand? If I had to give you like this assignment now that I gave you, right? This one that I said to is a reverse. It's the same thing as me saying, remember I told you when I was a kid, I had to fill up a drum and I had to loop it until the drum is full. That was the breakout. So this assignment 4 is just the reverse. It's just like my mom saying, Darlington, you see that drum with water? Take out the water from it until it's empty. So I have to take my bowl, take water, I have to go throw it outside, I have to loop until it's empty. So logically, it makes sense. So when you're solving this stuff, try to just think about it logically as well. What do I have to do first? So the first I have to do is I have to take a bowl of water, I have to take water out, go outside, throw it off, come back, take water out, throw it off. If I had to fill it up, if the loop was filling up, I have to go get from the well, fill it in. You get it? So just think about it like that. Don't think about it as one big math problem. If you do that, you're just going to quit. So just take it one step at a time. What do I know? How do I use what I know to solve the problem? And just keep breaking it down like that. And if you have questions while solving it, throw your questions in the group. It would be nice to see you guys help out each other. Or if something you guys can help, I'll just step in. Is it clear? Is there any questions with the assignment? Or any questions with anything we have discussed so far? No questions? Alright. So I would like to end the class here today. I'm really happy a lot of you showed up. Gosville, I would still encourage you to look at the videos. I sent a book in the WhatsApp group. See if you can catch up. You can, if you're solving a problem, you get stuck, you can always link up with me, send me a message, or I would rather any question you're asking about programming, please put the question on the group app. The reason for that is we all learn from each other. So the question you might have, one of the mates there can be able to solve it. Helping people helps you learn the program quicker. Or your question, somebody might not even know it, and me giving the answer in a public forum helps everyone understand the same solution. Okay? So I'm gonna ask a few questions just to see if everybody figured out what we learned today, right? I'm going to start with Constance. So, Constance, right? What is the JVM? Okay. Is okay. Is it IntelliJ that uses it, or is it Java that uses it? Okay, great. Thank you. We're gonna go to Obi. I've not heard Obi this morning. Obi. So, what is a bytecode? Okay. I wouldn't say door, but you're very close. Who can help out here? So you're on the right track. I just want it to be more clearer. So Chinoso, can you help out? Oh wait. Before Chinoso, Gospel, come on. Gospel, you're here. Let's go. Bytecode. It's okay if you don't know it. Okay, so Chinoso, let's give it a try. Okay, that's not the bytecode. That's the machine code. So try again. Bytecode. Who's gonna help us? Sumbo, shoot. Bytecode. But this is good. See, we're gonna figure it out very soon.
I think bytecode is what is translated to the computer, and then the computer translates the code to different windows, translates it to them in their own.
All right. Very good. Very close. But I just want you to use the right word. You said computer translates it. But let's try again. Ifeanyi, can you help? Okay. Now everybody has the answer all together. Let me mute my wife. So the answers are all in what you guys are saying, but I just want it to be the right way. So first of all, the JVM is not what compiles. The JVM reads and understands. So I'm gonna take you back to the image, then it will become clear again. So Java, if you're a developer, when you install the Java JDK, it comes with a program called the Java compiler. It's a separate program from Java. You have Java and you have Java compiler. The only people that use Java compiler are people like us, the developers, who are writing code. But if you have Java on your TV, Java does not have compiler on the TV. The Java that runs on your TV only has a JVM. So we that are the programmers, we are the ones that need compilers. That's why we're using IntelliJ. IntelliJ uses the compiler that is already installed in our computer because we downloaded. Because when you download IntelliJ, it downloads the compiler for you. Or if you download JDK directly by yourself, JDK actually means Java Development Kit. So you just go online. By the way, if I'm using words you guys don't know, please say it's JDK. So I'll just say Java. Let's see. So you see, JDK means Java Development Kit. JDK is so the JDK is what we as programmers use to write Java programs, and it comes with both Java and the Java compiler. So visually, yeah. So because we are programmers, when we are working, we have both the Java that can read, which is the JVM, and we also have the Java compiler. Java compiler compiles, when we're done writing our code, when we compile it, it compiles it into bytecodes. The only guy that can read this bytecode is our JVM. and the JVM is Java. You get it? So Java reads the bytecode and then converts our bytecode to machine code. So it does the work for us. So strongly typed language or high level language, you can hear the word high level languages or strongly typed languages, which are languages like C Sharp, Java, C++, they all use compilers. But non-strongly typed languages like JavaScript, TypeScript, uh, what do you call it, Python, they don't use compilers. But that's by the way. I just want you guys to know this process. Java compiler compiles your code into bytecode. The only guy that understands bytecode is your JVM. Your JVM takes your bytecode because your JVM itself does not understand this text you wrote. It doesn't understand it. That's where your compiler comes into play. So because of we are developers, our IntelliJ or when you download JDK yourself, it comes with Java compiler. And that's why I type Java C. Java C means compile what I wrote to bytecode. But if you're using IntelliJ, you don't have to do that. If you just press that play button, IntelliJ will do that for you. It will activate the compiler, take your codes and convert it to bytecode. And the bytecodes are those codes that end with .class. Then the JVM is now like, now I understand this guy. It takes your bytecode and then translates it to machine code. So this is a very good process you need to understand, right? And the while loop is, I think you guys probably know already how this works. The only thing you have to do now is just practice it. Thank you guys very much. I'm looking forward to you guys, putting in effort in this assignment, and I think it's gonna be fun. Do you understand? So thank you. I would say if there's no more question, I would say you guys have a great day, have a great weekend, and you're welcome. Please send in your assignment. Any of you that finish up your assignment on time, just send it. You understand? Because the earlier you send it, it will give me opportunity to look at it quicker. I might be able to give you guys great feedback earlier too. But just send your assignment as soon as you finish. You just send it. You don't have to wait till the end of the week. Okay? All right. You have a good one. Goodbye. Have a great weekend.